So remember when we used to do x and y coordinates, we go at 1, comma 2 and put a dot. With this problem, you want to do the same thing. Make your starting place the origin. So this person starts, I'm just going to make a dot here, and I'm going to pretend that's the center of the x and y grid. So this is at 0, 0. And if you go 3 miles at 20 degrees north of west, the length of this line here, this is west, right? So 20 degrees north of west would be up like this. I'm going to put a 3 here. And so that means we know what this angle would be. This would be 20 degrees. And so we could come up with a new coordinate for this new place and use that new coordinate to find the next coordinate for the next change, and then another coordinate. So we started at 0, 0. We made a 20 degree north of west change and went 3 miles. We want to know this new coordinate with respect to 0, 0 as our home coordinate. So that's right angle trig. We want to know the x and the y here. And so to find x, this would be the y coordinate. To find the change in the y distance, that's the opposite of 20. And we have the hypotenuse of this triangle that I drew. Right? So that's sine. Sine is the opposite divided by the hypotenuse. Sine of 20 equals the opposite divided by the hypotenuse. And with a calculator, make sure that's in degrees. 20 sine times 3. That's 1.026. So the y coordinate here is 1.026, I think I said. Yeah. Okay, and the x coordinate would be this distance on the triangle I drew. That's adjacent. That's not opposite. That's not hypotenuse. That means that's adjacent. And we still have the hypotenuse. We also could use the opposite right now, but we'll use adjacent over hypotenuse. That's cosine. Equals this adjacent that I don't know divided by the hypotenuse. So 20 degrees cosine times, oh no, typed over it, times 3, so we got 2.819. So 2.819. Okay, so went 3 miles, 20 degrees north of west. That puts us, if this is 0, 0, if our starting place is 0, 0, then our new coordinates are 2.819, comma 1.026. Okay, so let me redraw it so there's not as much clutter. Here we are at 0, 0. First change of direction brought us here. And then it says in 5 miles at 10 degrees west of south. So here's south, so this would be 10 degrees west of south. Okay, so if you're going this, if this is south, this is 10 degrees west of south, so we can make another right angle, south being straight down, and 10 degrees west of south looking like this. That's 5 miles, so we'll just do the same thing. To find this coordinate, then I want to find the change from this previous coordinate. I'll figure out this length, and I'll figure out this distance down, and then we'll have to, let's see, that's going to be adding to the x coordinate because we're going further on the x-axis, and then we're going down on the y-axis, so we should be subtracting these. And technically I should be putting this, I'm sorry I didn't write this, this is a negative 2.819, because when you draw your x and y coordinate system, these are the negative x values, right? We went up, that's why we're keeping that as a positive 1.026 for y. And then we went to the left on the x-axis, that's why I had to put a negative there. Okay, but we'll deal with that in a second. Let's do the same thing we just did in another problem to find this distance down here. That's opposite of 10 degrees. So sine of 10 equals the opposite, which I don't know, divided by the hypotenuse. So 10 degrees sine times 5. So that's 0.868. That's the change in x. And then for the y coordinate, the y change is going straight down this way, so that's the adjacent this time, which is different than last time, right? Same thing for x. X and y have switched. X before well, no, not x and y switch, sine cosine switch. Sine before helped us solve for y. Now sine's helping us solve for x because we went down instead of left. Okay, so we need to plug in cosine times 5. So y is 4.92. Let me just double check that because it seems kind of big. That might be right. Yeah, that sounds right actually. 10 for cosine times 5. Yeah, okay. So before I put these coordinates in, it's not 0.868 comma 4.92 because we're changing relative to this position, not to 0 comma 0. We went further back in the negative, so we went further to the left. So I'm going to take this negative 2.819 and subtract 0.868 from it. So it's now negative 3.687. So this is negative 3.687. And the y distance, we went down. So I started at positive 1.026, I went down 4.92. So I want to subtract those to get negative 3.894. Okay, and then what were we doing? 5 miles west to south, and then they went 4 miles at 15 degrees north of east. So from here, they went 4 miles, 15 degrees north of east. So here's east. If we go 15 degrees north of east, it looks something like this. So we just got to unfortunately repeat the process one more time. That's 15 degrees. So for this triangle, we got to find this new coordinate. We want to find the change in y, so that would be opposite. Oh, and sorry, I didn't label this. This is 4. That's the opposite divided by hypotenuse. Okay, so we got opposite. Sine of 15 equals the opposite divided by the hypotenuse. So we got 15 sine times 4. That's 1.035. So y is 1.035, and then the x distance on this triangle would be the adjacent. So cosine 15 equals the adjacent divided by hypotenuse. So 15 cosine times 4. So the x distance, the change in the x distance is 3.864. Okay, so that makes our new coordinates. The x distance got smaller, right? We started at negative 3.687. We got close to 0. In fact, we passed 0. So my drawing isn't quite to scale because it should be a little bit to the right of 0. So we got 3.864, take out that negative. Now we're at 0.177 for an x coordinate. And for a y coordinate, where are we at for a y coordinate? We started at negative 3.894, and then we went up 1.035 units. So that's increasing 1.035 because we went up, so this is our new y coordinate. So we're still below the origin. We're a little bit to the right of the origin now. So the last part of the question says, how far do we have to go to get back home? And in what direction? So we need to know the angle between these two. Here, let me just draw it where we ended up. Here's 0, 0, and then with a correction because I wasn't sure, my drawings were just estimates. We're a little bit to the right and still below. This is 0, 0, and then we're at 0.177, negative 2.859. Okay, so we need to know two things. We need to know this angle of how to get back home. We need to know this distance. So the distance is nice and quick because since this is the origin, this distance on the triangle is 2.859, and this distance is 0.177. I'm just rounding to make it a little easier. On the homework, you guys probably know I'm not too concerned about the decimal places. But so to find the diagonal distance, we just have to, oh, sorry, you can't see what I'm drawing. Let me repeat that. So down here, I drew the triangle. We start at 0, 0. we ended at 0.177 negative 2.86 roughly. Okay, so I drew a triangle, and this distance is 2.86. It should be negative, and then this is to the right. So we just need to use the Pythagorean theorem to find that distance. A squared plus b squared equals c squared. So to finish solving for this, we just take the square root. So 2.87 roughly. We have 2.87 units to get back home. And then to figure out this angle, you could use sine, cosine, or tangent. I'll just use tangent. Opposite divided by the adjacent. So tangent of the angle is the opposite, and drop the negative sign, divide by the adjacent. So 2.86 divided by 0.18, and then we need second and inverse tangent, like we saw before in the course. So it's an 86.4 degree, roughly an 86.4 degree angle that's north of west to get back home.